Bismillahirrahmanirrahim. Hello students, Assalamu alaikum. Welcome to the Electrical Engineering channel. In this video, I will discuss the Gaussian elimination method for solving simultaneous equations, and then I will discuss the LU factorization or LU decomposition method. So Gaussian elimination method, or it is also called Gauss elimination method, and it is used to solve n simultaneous equations. It has two steps. First step is forward elimination, and second step is backward substitution. And in this method, what actually has to be done is we are given a set of n simultaneous equations which can be represented in the matrix form, and we have to actually convert that system matrix into an upper triangular matrix. So this is an n by n or a 3 by 3 matrix. So first we have to make this entry equal to 0. Then we have to make this entry equal to 0. Then we have to make this entry equal to 0 and so on, such that only at the principal diagonal of this matrix and above this diagonal entries must be non-zero, and all the entries below this diagonal will be equal to 0. So what is the benefit of this method? If we use Gaussian elimination method first to find the unknown variables in n simultaneous equations, the order of solving those equations actually reduces. And if we have a 1000 by 1000 system and we have 1000 unknowns, then it is of paramount importance that our solver needs least and least computations. So the load on the solver or the computer must be as small as possible. Otherwise, we need higher processing and memory requirements to solve such huge systems. So when we have actually made all these entries equal to 0, this is called forward elimination. So starting from the second row, we have converted one entry equal to 0. Then we will move towards the third row and make this entry equal to 0 and make this entry equal to 0. And then we will move to the fourth row and so on. So we are moving forward and we are eliminating these entries. So that step is called forward elimination. So after achieving such upper triangular matrix, we have to first evaluate the last variable, right? So from this matrix, we can say that a 3 3 double dash into x3 is equal to b3 double dash. So x3 can be evaluated easily. So first of all, the last variable will be evaluated. Then we will write the equation of the second last row. A22 dash x2 plus a23 dash x3 is equal to b2 dash, and we know x3, right? So we can evaluate x2 easily. Then we will move to the first row, right? So starting from the last row, we are moving towards the first row. So this method is backward, and we are substituting all the known variables to find the next unknown variable. So that step is called backward substitution, right? So first of all, we will evaluate the last variable, then we will expand this equation and we will put the value of this last variable, and we will find out the value of the second last variable, and then we will move towards the upper row, and that method is called backward substitution. So these are the two steps which are involved in Gaussian elimination method. And now the thing is that how we have to make these entries equal to 0. So that method is very simple, and these are our n simultaneous equations which are written over here. And first, the first row will not be changed and it will stay as it is. And we have to make this first entry of the second row equal to 0. So first entry of the second row can be made equal to 0 if we have such an equation whose first entry is equal to the first entry of the second row. So that can be achieved by multiplying the first row by a21 over a11, right? So if I multiply this whole equation by a21 over a11, then my first entry will become a21x1, and these all entries will also change, and my new equation will become a21 x1 plus a21 over a11 into a12 x2 plus a21 over a11 into a13 x3, right? So if I multiply this equation by a21 over a11, then it will become a21 x1 plus a21 over a11 into a12 x2 plus a21 over a11 into a13 x3 plus so on, and it will also become a21 over a11 into b1. So this is the equation that I have obtained. I have to subtract this equation from the second equation, right? So this is my second equation. This is my new equation. So if I subtract this equation from this one, I will get 0 at the first place, and then this minus this will be equal to a22 minus a21 over a11 into a12 into x2 plus a23 minus a21 over a11 into a13 into x3 plus so on, and this minus this will be equal to this and equal to b2 minus this. So okay, so b2 minus a21 over a11 into b1. So this is my new second equation. So first entry in the second equation is eliminated, so it is starting from x2. So we will have to repeat the same procedure for the other equations as well. So for the third equation, we will perform the same procedure, but we will multiply the first equation by a 3 1 over a11, the whole equation, then subtract this equation from the third equation. Again, the first entry of the third row will become equal to 0, and all other entries will also change. And at the end, we will have such set of equations. So first entry of the second row and the third row are equal to 0 now, and these right hand side entries have also changed, and these coefficients have also changed. So a22 dash is equal to a22 minus a21 over a11 into a12, right? So this is our a22 dash, this is a22 dash, this is a23 dash, this is a2n dash, and this is b2 dash, and their values are summarized over here. Okay, so this is a22 dash, a23 dash, this is b2 dash, this is a32 dash, a33 dash, and this is b3 dash. So this is what we have obtained now. So now we have to make this entry equal to 0, and for making this entry equal to 0, we will use this second equation. So this entry a11 is actually called pivot. Okay, so we have to divide the first equation by a11 and multiply it by a21. If we are eliminating the first entry of the second row, if we are eliminating the first entry of the third row, then we will multiply the first equation by a31 over a11. So a11 is common, so that is called pivot. So if we use a11 as pivot, our these entries of the first column will become equal to 0. So if we want to make this entry equal to 0 now, we will use this entry as a pivot, right? So a22 dash will become our pivot, and we will multiply this first equation by a32 dash over a22 dash, this whole equation, and subtract it from the third equation. So this entry will become equal to 0, and this entry and this entry, they will also change. So you can see over here, so they has been renamed as a33 double dash and b3 double dash because they have also been changed, and these entries have become equal to 0, and a33 double dash is equal to a33 dash minus a32 dash over a22 dash into a23 dash. Similarly, b3 double dash is equal to b3 dash minus a32 dash over a22 dash into b2 dash. So this is all what we have to perform on n simultaneous equations, and after achieving such a form of the simultaneous equations, we can now start the backward substitution, which will easily give us all the unknown variables. And this whole procedure seems quite lengthy and laborious if we perform it by our hand on paper, but we can do MATLAB coding for this. Okay, so I will show you the MATLAB code which will do all these steps for us in a very simple way. So I can show you this whole discussion over here. So these are our n simultaneous equations, and here you can see that we are eliminating the first entries, and at the end we will have such form of the simultaneous equation. So this is a very simple code, and we can implement this code in MATLAB and run it, and it will give us our required answer. So you can see this is our system matrix, and we can achieve the upper triangular matrix from this system of three equations um, using this MATLAB algorithm. So this is our actual matrix, and this is a 3 by 3 matrix, 25, 5, and 1, and this is the entry which is the column vector at the right hand side. So 106.8, 177.2, and 279.2, they have also been included over here. And if we write such a simple code and run it, let's run this code, and you can see this is our original G matrix, and these are our right hand side column vector entries, and this is our upper triangular matrix, and these entries have also changed, right? So by using this code, we can achieve this Gaussian elimination, and we can uh, use any system of matrix, any order of the matrix. For example, 100 by 100 system can also be solved using these simple lines. Okay, so that was one thing of achieving Gaussian elimination algorithm in MATLAB, right? So after achieving such upper triangular matrix, backward substitution can be done to evaluate the unknown variables. Now another thing is LU factorization, right? So LU factorization is also called LU decomposition, and in LU decomposition, we have to decompose our system matrix A into an upper triangular matrix and a lower triangular matrix. So this is our system matrix AX is equal to B. After Gaussian elimination, this A matrix will be transformed to this form, and we will have B1, B2 dash, B3 double dash over here, and this is our U matrix. So UX is equal to Y. So we have renamed this column vector to Y. Initially it was column vector B. So Ux is equal to Y, and we know that Y is equal to this column vector B1, B2 dash, B3 double dash, and it can be written as B1, B2 dash is equal to B2 minus A21 over A11 B1, and B3 double dash can be written as B3, it can be written as B3 dash, right, minus A32 dash over A22 dash into B2 dash, and B3 dash is equal to B3 minus A31 over A11 into B1. So we have to translate B3 dash to this form, but this form will stay as it is. So why I am doing this, you will know later. Okay. So this Y column vector can be multiplied with an identity matrix, and there will be no harm to it. So Y column vector is Y1, Y2, Y3, and I have multiplied an identity matrix over here, and this is our right hand side column vector. So this is B1, and this is B2 minus A21 over A11 B1, and this is B3 minus these terms, right? So this is B1, right? And B1 is equal to Y1. Okay. So if I expand this first row, it will be Y1 is equal to B1. Okay, so it means Y1 is equal to B1. So I can write Y1 over here. In the second entry, I can write Y1. I won't write anything for it, but for the second entry, I can write Y1 over here. And similarly, I can write Y1 over here in place of B1. And I can write Y2 over here in place of B2 dash, because this entry is B2. This second entry is B2 dash. Okay, this second entry is B2 dash, and this B2 dash is equal to Y2. Okay, so this Y2 is equal to B2 dash. So in place of B2 dash over here, I will write Y2, I will write Y1 over here, and I will write Y1 over here. I won't change these entries. So these entries will become like this: B1, B2, B3, Y1, Y1, and Y2. And now uh, these entries, this entry can be taken to the left hand side and it will become plus A21 over A11. And since this entry is multiplied with Y1, so this entry will take the place of this 0, right? Because this entry has to be multiplied with y1. So a21 over a11 will be placed over here with a positive sign. Similarly, a31 over a11 will be placed over here with a positive sign, because this entry is also being multiplied by y1, and the entry over here will be multiplied with y1 if I expand this row. Similarly, this entry will take the place of this 0 with a positive sign, because this is multiplied with y2 and this entry has to be multiplied with y2. So our new system will become y1, y2, y3, 1, 0, 0, b1, b2, b3, and these entries will take the place over here with positive sign. So now this is my lower triangular matrix. This is my y column vector and this is my b column vector. So Ly is equal to b, and from the first equation, y is equal to ux. So I can substitute y equal to ux over here. So it will become Lux equal to b, and we also know that ax is equal to b. So by comparing these two equations, a is equal to Lu. So this uh, phenomena is called Lu factorization or Lu decomposition, and by this procedure we can transform any system matrix to a lower and an upper triangular matrix. So A matrix can be decomposed into a lower triangular matrix and an upper triangular matrix. And when you multiply these two matrices, you must get the original A matrix. Okay, so system matrix is the product of upper and lower triangular matrix. And this whole procedure can be achieved by using this MATLAB script. And in this MATLAB script, you can see so this is again the solution of simultaneous equations by LU decomposition method. And here these are all the same steps which I have just discussed, and this is the MATLAB code, and I can transform this matrix into L and U matrices. Similarly, this matrix can also be decomposed and we can check whether it works or not. So this is one matrix. Okay, so this is this matrix. So I have specified this matrix over here, and you can write these as simple lines, and at the end you can take the product of L and U matrices. Let's run this code, and you can see this is my G matrix, this is the upper triangular matrix, this is the lower triangular matrix, and when I multiply these two matrices, I get the same system matrix. So this code works correctly, and I can change my system matrix to this one: 2 5 10 2 minus 9 1 0 8 4. Now let's again run this code, and you can see this is my upper triangular matrix, this is my lower triangular matrix, and this is the product. So the product of L and U matrices is equal to the original system matrix. So that is all about our today's lecture, and I hope you have understood the concept which is discussed in this lecture on Gaussian elimination and LU decomposition methods. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.